Imagine waking up one morning to discover that a star you've casually observed throughout your entire life, perhaps even using as a reference point for finding constellations in the night sky, has simply vanished without a trace. Not gradually dimmed over centuries as aging stars naturally do. Not exploded in a spectacular, brilliant supernova visible across vast cosmic distances. Just gone. Erased. Absent. As if someone with unimaginable power reached up into the heavens and switched it off like flipping a common light switch. For centuries spanning human civilization's development, astronomers have painstakingly cataloged millions upon millions of stars scattered across our galaxy and beyond, meticulously tracking their precise celestial positions, their apparent and absolute brightness, their complex life cycles, with extraordinary precision refined over generations of careful observation. We understand with remarkable confidence how stars are born, emerging from collapsing clouds of molecular gas and dust called stellar nurseries, regions where gravity overcomes thermal pressure, causing material to concentrate and heat until nuclear fusion ignites in nascent stellar cores. We know intimately how they live their lengthy existences, steadily fusing hydrogen nuclei into helium in their superhot cores for millions, billions, even trillions of years, depending on their initial mass and resulting internal physics. We've extensively documented, through both observation and rigorous theoretical models, how they die, either fading quietly and gradually as cooling white dwarfs, radiating away residual thermal energy over incomprehensible timescales, or detonating violently as supernovae that briefly outshine entire galaxies, containing hundreds of billions of stars. But what astronomers are witnessing now in multiple independent observational campaigns challenges fundamentally everything we thought we thoroughly understood about stellar evolution and the life cycles governing stars. Stars are disappearing from our observable sky without displaying any of the characteristic expected signs, without providing advance warnings that something unusual is occurring, without leaving behind the extensive debris fields or distinctive radiation signatures that should inevitably accompany their deaths according to well-tested astrophysical models refined over decades. These aren't ancient historical mysteries recorded in fading manuscripts housed in dusty archives, ambiguous observations documented centuries ago when astronomical instruments were primitive and imprecise. These are modern, contemporary observations, captured by sophisticated telescopes equipped with advanced digital sensors, documented in comprehensive digital databases, accessible to researchers worldwide, verified independently by multiple skilled observers using different instruments at different geographic locations. And the international scientific community finds itself genuinely struggling to formulate adequate explanations for what's systematically happening across our observable universe. The universe we observe and study operates fundamentally on timescales that utterly dwarf human experience and intuition. Individual stars live for timeframes measured in millions, billions, even trillions of years, depending critically on their mass and resulting internal structure. Entire galaxies containing hundreds of billions to trillions of stars evolve gradually over cosmic eons, stretching across billions of years. The fundamental forces of physics that govern all matter and energy remain essentially constant across both space and time throughout the observable universe, creating predictable patterns. Everything in professional astronomy typically happens gradually, predictably, mathematically, according to well-tested physical laws verified through countless observations. Except when, suddenly, inexplicably, it doesn't follow those rules. Between comparison years spanning our recent comprehensive astronomical surveys, over 100 individual stars have simply vanished completely from detailed sky catalogs compiled with modern precision. These aren't stars that move to different celestial positions, which would naturally indicate proper motion as they orbit through the galaxy alongside billions of their stellar neighbors. These aren't stars that dimmed below our detection threshold due to natural variability or obscuration by intervening dust clouds passing between us and distant stellar sources. These are stars that vanished, completely and utterly, leaving absolutely no detectable trace, no physical remnant, no satisfactory explanation based on our current comprehensive understanding of astrophysical processes governing stellar behavior. This phenomenon isn't a simple measurement error or routine cataloging mistake that happens occasionally when comparing astronomical databases compiled at different times. These represent real, extensively documented observations systematically comparing historical photographic plates and early digital surveys with modern ultra-sensitive digital sky surveys covering precisely the same regions of three-dimensional space. When professional astronomers carefully overlay these temporally separated images using sophisticated alignment algorithms, comparing past observations with present observations, they consistently find specific, individual stars that verifiably existed and were documented decades or even a century ago, but are simply, inexplicably, absent now from the exact same celestial coordinates. The precise coordinates in our celestial coordinate system remain mathematically identical across these temporal comparisons. The surrounding neighboring stars scattered across the same region of sky remain perfectly visible with unchanged brightness and spectral characteristics. But specific, individual target stars, sometimes dozens within relatively small surveyed regions, have been effectively erased from observable existence through unknown mechanisms. The most unsettling, disturbing part of this discovery isn't merely that stars are vanishing from our observable universe at a measurable rate. It's specifically that they're vanishing through processes and mechanisms that shouldn't be physically possible, according to literally everything we collectively know about how the universe fundamentally works based on centuries of accumulated astronomical knowledge. When a star dies naturally through any process predicted by stellar evolution theory, it inevitably leaves behind clear, unambiguous evidence accessible to modern instruments. A low-mass star like our Sun eventually becomes a white dwarf, an incredibly dense stellar remnant composed primarily of electron-degenerate carbon and oxygen, gradually cooling over billions upon billions of years while remaining forever detectable through the thermal radiation it emits. A more massive star expels its outer layers during its death throes, creating a beautiful, expanding planetary nebula, visible for tens of thousands of years as the ejected material disperses into surrounding interstellar space. The most massive stars detonate as core collapse supernovae, leaving behind either an ultra-dense neutron star composed entirely of neutrons packed to nuclear density, or a black hole whose intense gravitational field warps space-time itself into a region from which not even light can escape. But these mysterious vanishing stars we're documenting leave absolutely nothing, no detectable remnant whatsoever behind to study, analyze, or even confirm their previous existence beyond the historical records proving they once shone in our sky. Some proportion of these documented missing stars were classified as red giants or red supergiants in their final observations before disappearance. These are massive, highly evolved stars that have exhausted hydrogen fusion in their cores and expanded to enormous sizes while fusing progressively heavier elements. Such stars should end their stellar lives in absolutely spectacular supernova explosions, theoretically visible across millions of light-years of space. Events so energetically intense they briefly rival the luminosity of entire galaxies. Those cataclysmic explosions should be readily detectable not just through visible light observations, but comprehensively across the entire electromagnetic spectrum, spanning many orders of magnitude in wavelength. Long-wavelength radio waves produced by synchrotron radiation from relativistic electrons, infrared radiation from heated dust clouds, optical and ultraviolet light from the explosion's photosphere, X-rays from shocked gas heated to millions of degrees, and even gamma rays from radioactive decay of unstable isotopes synthesized during the explosion. Supernovae rank among the absolute most energetic events occurring anywhere in the observable universe. We routinely detect and study them in extremely distant galaxies located billions of light years away across cosmic space. Yet somehow, impossibly, these relatively nearby stars manage to completely disappear without producing even a trace of that absolutely characteristic multi-wavelength radiation signature that should inevitably accompany any stellar death of this magnitude. Other documented vanishing stars were classified as main sequence stars essentially identical to our own middle-aged sun, stable stars that should theoretically have billions of years of steady, predictable hydrogen fusion remaining in their cores before they even begin approaching the initial stages of stellar death. These particular stars shouldn't be dying at all based on standard stellar evolution models, let alone vanishing without leaving any detectable trace. They're in the prime of their stellar existence, steadily converting hydrogen nuclei into helium through nuclear fusion, radiating energy continuously into surrounding space, presumably gravitationally bound to any planets or other objects that might orbit them in stable planetary systems. What conceivable physical mechanism could possibly make such fundamentally stable stars simply cease to exist entirely, vanishing from observable reality? When professional astronomers initially first noticed these striking discrepancies between historical and modern surveys, the immediate natural assumption, based on scientific caution, was observational error or systematic database issues. Perhaps the historical photographic surveys conducted decades ago, with less sophisticated equipment, misidentified the star's precise celestial position due to photographic plate distortions or imperfect calibration. Perhaps the modern digital surveys were inadvertently looking at slightly incorrect coordinates due to coordinate system transformation errors, or proper motion corrections applied incorrectly. Perhaps variable atmospheric conditions during historical observations, or fundamental telescope limitations, created false detections in old photographic plates that never actually corresponded to genuine astronomical objects existing in physical space. Science always properly begins by rigorously questioning the observation methodology itself, examining potential sources of instrumental or systematic error before accepting extraordinary conclusions that might require revision of fundamental theories. This skeptical approach represents sound scientific methodology, refined over centuries. But as more and more independent examples steadily accumulated across multiple surveys and observation campaigns, as additional independent researchers systematically verified the exact same apparently missing stars in multiple completely independent datasets compiled using different instruments and methods, as sophisticated statistical analysis techniques definitively ruled out simple random error or statistical fluctuation as plausible explanations, the broader astronomical community had to confront an increasingly uncomfortable reality that resisted easy dismissal. These controversial stars genuinely, verifiably existed in the observable past, based on multiple, completely independent observations documented in different surveys conducted at different times. They genuinely, demonstrably don't exist in observable reality now, based on equally reliable, actually more sensitive modern observations that should detect them easily if they remained present. Some unknown mechanism or process is systematically removing stars from our observable universe at a measurable rate that exceeds what stellar evolution theory predicts. Let me walk you through several specific, documented cases in careful detail, because the precise observational details matter enormously for evaluating competing hypotheses. One particularly troubling, extensively discussed example involves a massive red supergiant star, properly cataloged in multiple independent historical astronomical surveys dating back several decades into the mid-20th century. Red supergiants represent among the absolute most intrinsically luminous stars existing anywhere in the universe, routinely shining with the combined light output of hundreds of thousands of sun-like stars, making them extraordinarily conspicuous and essentially impossible to overlook or miss if they're genuinely present in the observed field. This particular enigmatic star clearly appeared in historical photographic survey plates with sufficient brightness and clarity to rule out detection artifacts. It appeared in detailed spectroscopic studies that analyzed its light in detail, confirming its red supergiant classification through characteristic spectral features. It even appeared in specialized infrared surveys specifically designed to target cool, highly luminous stars exactly like red supergiants, which emit most of their prodigious energy output at longer infrared wavelengths. Then, mysteriously, between two separate survey observations separated by just a few years, barely a cosmic eye blink, it completely vanished, without any documented intermediate observations capturing the disappearance process. Modern, powerful telescopes equipped with ultra-sensitive digital detectors pointed precisely at those exact verified historical coordinates find absolutely nothing where this luminous red supergiant should still be shining brilliantly. No red supergiant star visible in any wavelength. No expanding supernova remnant that would indicate a recent explosive death. No glowing debris cloud containing ejected stellar material. No characteristic radiation signature whatsoever indicating a recent or ancient stellar death occurred at that location. Just completely empty space, with distant background stars visible exactly as they should appear if nothing substantial or massive had ever existed at that specific foreground location. The total energy required to completely make a red supergiant star disappear without any detectable trace is almost incomprehensibly enormous, straining human intuition. We're discussing a star possessing a total mass 10 or perhaps 20 times greater than our entire Sun, with a physical volume so unimaginably enormous that if you hypothetically place this giant star precisely where our Sun currently sits at the center of our solar system, its extended outer atmosphere would physically reach past Earth's orbit, potentially extending even beyond Mars depending on the specific star's exact size. That's not something minor or insignificant that just vanishes quietly into nothingness without consequence. If such a massive star exploded violently as a supernova, the resulting explosion would be clearly visible to astronomers for months or even years as the expanding debris cloud radiated away its kinetic energy. If instead, the star's core collapsed directly into a stellar mass black hole through gravitational collapse, we would definitely detect the powerful gravitational waves rippling through space-time from that catastrophic collapse event, and subsequent observations would detect the black hole's ongoing gravitational effects on surrounding space, neighboring stars, or any gas attempting to accrete onto it. But there's absolutely nothing detectable through any observation method. Complete mysterious absence where a brilliant, massive supergiant star should either still exist, shining steadily, or should have left extensive, clear evidence of its recent, dramatic demise. Another significant category of potentially vanishing stars involves what theoretical astrophysicists call failed supernovae, predicted but never definitively confirmed events. When a sufficiently massive star completely exhausts all possible nuclear fuel in its core, having fused elements progressively up to iron, which cannot undergo further exothermic fusion, the core collapses catastrophically within mere seconds, as quantum degeneracy pressure fails to counteract gravitational pressure. Usually, this sudden, violent collapse triggers a powerful rebound shockwave that propagates outward through the star's extended envelope, blowing the outer layers explosively into surrounding space at thousands of kilometers per second, creating the brilliant, spectacular supernova explosion we observe from immense distances. But occasionally, according to some theoretical models based on detailed computer simulations of stellar core collapse, the collapse could, hypothetically, continue directly to immediate black hole formation, without successfully launching the outward shockwave. A failed supernova scenario, where the entire star essentially implodes into gravitational darkness within seconds, falling through its own event horizon. Failed supernovae could potentially explain some observed vanishing stars, if this theoretical process actually occurs in nature. The massive progenitor star collapses, rapidly forms a stellar mass black hole, and suddenly appears to vanish from visible light observations, because black holes, by definition, don't emit radiation from within their event horizons. But even this superficially appealing explanation encounters serious, perhaps fatal, problems when examined critically in detail. First, we should still clearly observe the massive supergiant star shining normally right up until the final moment of catastrophic collapse, which occurs over a timescale of mere seconds. Astronomical surveys separated by years or entire decades shouldn't coincidentally catch numerous stars during that incredibly brief collapse moment unless failed supernovae are vastly more common in nature than current theory confidently predicts, which would itself represent a significant challenge to stellar evolution models. Second, even a so-called failed supernova should inevitably produce multiple detectable signals accessible to modern instruments. The infalling stellar material plunging into the rapidly forming black hole should emit copious X-rays and gamma rays as it heats to millions or billions of degrees, while spiraling inward through the accretion disk forming around the nascent black hole. Neutrinos carrying away enormous amounts of gravitational binding energy from the collapsing core should be directly detectable by specialized neutrino observatories like IceCube or Super Kamiokande, continuously monitoring for these elusive particles. The intense gravitational waves propagating outward from the asymmetric collapse should create detectable ripples in spacetime itself, measurable by our increasingly sophisticated network of gravitational wave detectors like LIGO and Virgo. We're not observing any of these confidently expected signals associated with the documented vanishing stars when we examine archival data from relevant instruments. Third, the newly formed stellar mass black hole should still remain readily detectable through its powerful gravitational influence on surrounding space and nearby objects. If a 20 solar mass star catastrophically collapses to form a black hole, that resulting black hole retains exactly 20 solar masses worth of gravitational attraction, affecting everything nearby. If the vanished star possessed any binary companion stars, those companions should continue orbiting the now invisible black hole in perfectly detectable patterns measurable through careful astrometry and radial velocity studies. If surrounding gas exists in the vicinity, it should gradually accrete onto the black hole, heating and emitting X-rays in the process. We're not observing these expected gravitational effects or accretion signatures either in follow-up studies of vanishing star locations. So failed supernovae, while theoretically possible according to some sophisticated computer models of stellar death, demonstrably don't adequately explain the accumulating observations we're systematically collecting across multiple surveys. Something fundamentally else is occurring. Something we don't yet have a comfortable natural explanation for within our current astrophysical framework. Some researchers working on this mystery have proposed that dense molecular clouds, thick accumulations of interstellar dust and gas particles, could potentially be moving through three-dimensional space and obscuring these specific stars from our terrestrial viewpoint. When a particularly dense cloud passes between Earth-based observers and a distant stellar source, the intervening material can absorb and scatter the star's light, causing the star to appear significantly dimmed or even to vanish completely behind the optically thick, obscuring material. This well-known and thoroughly documented phenomenon in professional astronomy is called interstellar extinction. But interstellar extinction demonstrably doesn't explain these particular observations adequately for multiple compelling physical reasons. First, extinction affects electromagnetic radiation across all wavelengths, but particularly preferentially blocks shorter wavelength light like blue and ultraviolet photons, while allowing significantly longer wavelengths like red optical light and especially infrared radiation to pass through the dust with much less absorption. A star genuinely obscured by intervening dust should therefore appear substantially dimmed and dramatically reddened in color temperature, but should still remain clearly detectable in infrared observations using specialized infrared telescopes or space-based infrared survey missions. The mysterious vanishing stars we're systematically documenting aren't showing this absolutely characteristic signature that extinction invariably produces. They're simply completely absent across essentially all observed wavelengths from infrared through visible to ultraviolet. suggesting complete disappearance rather than selective wavelength-dependent obscuration. Second, a molecular cloud sufficiently large and dense to completely hide a luminous star from detection would itself be easily, readily detectable through multiple independent methods. The cloud would emit its own thermal infrared radiation as interstellar dust grains absorb stellar light and re-radiate that energy at longer wavelengths. The cloud would produce observable effects on background stars, creating a region where numerous stars simultaneously appear dimmed and reddened rather than single isolated stars vanishing while all their immediate stellar neighbors remain perfectly visible with unchanged brightness. Third, molecular clouds aren't stationary in space, but move through the galaxy at measurable, trackable velocities, typically ranging from several to tens of kilometers per second. If a particular cloud obscured a specific star decades ago during historical surveys, it should have physically moved on by now, revealing the previously hidden star again in modern observations. Alternatively, if the cloud is obscuring the star currently in modern surveys, historical observations should clearly show the star's gradual, progressive dimming as the cloud slowly approached and then passed in front, not sudden, inexplicable disappearance between discrete observation epochs. The obscuration hypothesis is natural, comfortable, doesn't require invoking any new exotic physics or revising fundamental astrophysical principles. But it simply, demonstrably, doesn't match what we're actually observing when we examine the data carefully. Now let me introduce the hypothesis that makes many conservative scientists deeply uncomfortable, but that we must consider seriously, because genuinely extraordinary observations demand we rigorously examine all theoretically possible explanations, even profoundly uncomfortable ones that challenge our assumptions. What if at least some significant fraction of these systematically vanishing stars aren't vanishing through any natural astrophysical process? What if they're being deliberately obscured or systematically dismantled by hypothetical advanced technological civilizations, harvesting stellar energy on incomprehensible scales? This hypothesis sounds initially like pure science fiction narrative, frankly. And most professional astronomers' immediate instinct, based on training and experience, is to dismiss it without serious consideration. Scientists are rigorously trained through years of education to seek natural explanations first, to invoke the philosophical principle called Occam's razor, and systematically choose the simplest hypothesis that adequately explains all observations without introducing unnecessary assumptions. Hypothetical alien megastructures surrounding stars are definitely, emphatically not the simplest possible explanation, by any reasonable measure. But here's the genuine intellectual challenge we collectively face when confronting this data. If literally all the conventional natural explanations we can propose fail to adequately account for the systematic observations accumulating across multiple independent surveys, if failed supernovae don't fit the observational constraints, if interstellar obscuration doesn't fit the wavelength-dependent signatures, if our entire comprehensive understanding of stellar evolution and stellar death processes says unequivocally these disappearances shouldn't be physically happening through natural means, at precisely what evidential point do we become obligated to seriously consider alternative hypotheses, even if those alternatives are extraordinary and paradigm challenging? The fundamental concept astronomers discuss is called a Dyson sphere or Dyson swarm, originally proposed by brilliant theoretical physicist Freeman Dyson in the 1960s during early SETI discussions. Dyson reasoned logically that any advanced technological civilization would inevitably have continuously increasing energy needs as their technology and population developed over time. Eventually, inevitably, the total energy available on a single planet's surface becomes fundamentally insufficient for supporting an expanding advanced civilization, regardless of how efficiently they use that energy. The logical next step in technological development would naturally be capturing energy directly from the host star itself, which outputs literally millions or billions of times more total energy than reaches any single orbiting planet's surface. Our own sun radiates approximately 400 trillion watts continuously into surrounding space. Earth intercepts only about 1/2 billionth of that total output. The remaining energy simply radiates away into empty space, unused, wasted. A Dyson sphere, in its original theoretical conception, would be a solid shell completely surrounding a star at some optimal orbital distance, capturing essentially all the star's radiant energy output for utilization by the civilization. Modern structural analysis suggests that configuration is probably not practically feasible, given material strength limitations and orbital mechanics complications. The more realistic engineering version is what's called a Dyson swarm. Millions or potentially billions of individual solar collectors in independent, stable orbits around the star, collectively capturing most of the star's light output while remaining structurally simpler. From an external observer's perspective, located many light years away, a star completely surrounded by a finished or near-complete Dyson swarm would appear to dramatically vanish in visible light observations. The star's optical and ultraviolet light would be efficiently absorbed by the energy-collecting megastructure, converted to useful work or stored energy, and the inevitable waste heat, according to thermodynamics, would be radiated away primarily as infrared radiation at wavelengths determined by the structure's operating temperature. External observers would see a bright infrared source, potentially extremely bright depending on the collected energy and radiating temperature. Where a visible optical star used to shine brightly. And that's precisely what professional astronomers systematically search for when they conduct surveys specifically looking for potential Dyson spheres or similar hypothetical megastructures, astronomical objects that appear prominently in sensitive infrared surveys, but are conspicuously absent or dramatically fainter in visible light surveys of the same sky regions. Or known stars that show unusual substantial infrared excess, suggesting significantly more infrared emission than the star's measured temperature alone should naturally produce. Interestingly and provocatively, several of the documented vanishing stars do show peculiar, unexplained infrared signatures in observations conducted before they vanished completely from detection. Not necessarily the steady, gradual infrared excess you might theoretically expect from a Dyson swarm slowly under construction over decades, but rather fluctuating, highly variable infrared emission that doesn't match any standard stellar behavior or known astrophysical variability mechanism. Could this observed variability potentially represent different progressive stages of megastructure construction observable as the project advances? Early construction stages where partial coverage of the star creates variable obscuration as different orbital sections get built. Advanced near completion stages where nearly complete stellar coverage still allows occasional brief glimpses of the star through temporary gaps in the structure that close over time. The observed timescales present another genuinely fascinating puzzle worth examining carefully. If we're actually witnessing technological megastructures being systematically constructed around multiple stars, the construction appears to be happening remarkably, almost impossibly quickly on cosmic timescales that normally measure stellar processes in millions of years. We're discussing stars vanishing over observed periods of mere years, or at most a few decades, barely an eye blink in cosmic time. Not the millions of years you might naively expect megastructure construction to require. That observation implies either extraordinarily rapid construction capability, far beyond anything human civilization could currently achieve or even seriously contemplate with foreseeable technology, or, alternatively, we're coincidentally observing many independent civilizations scattered across our galactic neighborhood, all at remarkably similar technological development stages simultaneously, which itself raises profound statistical questions about the distribution of technological civilizations through cosmic time. Let me directly address the obvious, inevitable objection that skeptics immediately raise. Wouldn't we necessarily detect numerous other clear signs of advanced technological civilizations if they're common enough to be actively building energy-harvesting Dyson spheres around multiple nearby stars within our local galactic neighborhood? Wouldn't we inevitably see deliberate radio signals, optical laser signals, obvious evidence of their industrial technology and activities beyond just these hypothetical megastructures? Perhaps we should detect such signals, yes. But consider carefully that our own human technological civilization has existed for barely over a single century, measured against cosmic timescales. Radio transmission technology has existed for roughly 120 years. Our absolute most powerful deliberate signals intentionally transmitted towards space hoping for interstellar reception are only a few decades old and haven't even reached nearby stars yet. And significantly, human civilization is already rapidly moving toward progressively more efficient communication technologies that deliberately leak dramatically less stray radiation into surrounding space compared to early broadcast technologies. Fiber optic cables don't radiate detectable signals into space at all. Tightly focused directed laser communications don't broadcast omnidirectionally for anyone to intercept. An advanced technological civilization, even moderately more developed than ours, might be essentially completely radio quiet from external observation, detectable only through their absolute largest mega engineering projects, like stellar-scale energy collection, rather than through communications we'd recognize. Moreover, the enormous distances involved matter tremendously for signal detection. Most of these documented vanishing stars are located hundreds or even thousands of light years away from Earth, across interstellar space. Any radio signals transmitted from civilizations at those distances would have been originally transmitted hundreds or thousands of years ago, in the civilization's own time frame. If they've technologically moved beyond wasteful radio broadcasting and their subsequent development, we might never detect those brief signals even if they existed temporarily in that civilization's history, before they developed more efficient alternatives. The Dyson sphere hypothesis makes specific, testable predictions accessible to current observational technology. If these vanishing stars are genuinely being progressively surrounded by energy-collecting megastructures, we should detect them as unusual, distinctive infrared sources with characteristic properties. An artificial structure radiating waste heat from captured stellar energy collection would necessarily appear as a strong infrared source with a characteristic thermal temperature signature, probably somewhere between roughly 300 and several thousand degrees Kelvin, depending on the specific engineering design choices and thermodynamic efficiency achieved. Professional astronomers have actually conducted systematic searches for exactly these distinctive signatures, using available infrared survey data. The most comprehensive search to date carefully examined extensive data from the WISE Infrared Space Telescope, which systematically surveyed the entire accessible sky in multiple infrared wavelengths, creating an unprecedented database. Researchers methodically looked for astronomical objects that appeared bright and prominent in infrared observations, but had no corresponding visible light detection whatsoever, or alternatively known stars showing substantial infrared excess, dramatically inconsistent with normal stellar physics predictions. The search teams found candidates, dozens of intriguing objects showing approximately the expected signature profile. But here's where the detailed analysis becomes genuinely complicated and ambiguous. Many of these candidate objects have plausible alternative natural explanations that can't be definitively ruled out without additional data. Dust-shrouded forming stars appear remarkably similar in infrared properties. Debris disks surrounding relatively young stars naturally produce infrared excess. Even certain types of highly evolved stars in specific evolutionary stages create similar infrared signatures through natural circumstellar dust production. Distinguishing definitively between a genuine Dyson sphere and a natural astrophysical object producing similar, observable infrared properties requires extensive, detailed follow-up observations. High-resolution spectroscopy to analyze exactly what specific wavelengths the mysterious object emits, revealing chemical composition and physical processes. long-term systematic monitoring to determine if the infrared emission changes detectably over months or years, in ways suggesting construction activity versus natural variability. Most of these intriguing candidates remain frustratingly ambiguous, potentially artificial megastructures, potentially exotic natural objects, genuinely requiring substantially more observational data for drawing definitive conclusions. But some small fraction of the candidates discovered are genuinely difficult to explain satisfactorily through any conventional natural mechanisms we currently understand. They show observational characteristics and properties that don't quite fit comfortably into any standard, well-understood astrophysical object category. Not massive enough to represent forming stars based on infrared luminosity. Wrong characteristic temperature for typical circumstellar debris disks. Spectral features that don't match dust-enshrouded evolved stars. They exist uncomfortably in this ambiguous observational zone, where natural explanations seem forced and require multiple coincidences, while artificial technological explanations seem too extraordinary to accept confidently without substantially more compelling evidence. One particularly interesting and extensively studied candidate is a star that became famous worldwide as Tabby star, or Boyajian star, named after astronomer Tabitha Boyajian, who first published detailed, comprehensive analysis of its absolutely bizarre, unprecedented light curve behavior. This star showed periodic dips in observed brightness, but critically, not the regular, predictable periodic dips characteristic of an eclipsing binary star system or a transiting exoplanet system would naturally produce through straightforward geometric occultation. Instead, the dimming events appeared irregular and aperiodic, unpredictable in their timing. Sometimes, the star would dim by just a few percent, barely noticeable variations. Sometimes, it would dramatically dim by over 20%, unprecedented for a star of this type and age. The individual dimming events lasted dramatically different lengths of time, from mere hours to extended weeks. And crucially, the pattern didn't repeat regularly or predictably, like natural periodic astronomical phenomena invariably do. This highly unusual behavior became internationally famous, generating enormous public and scientific fascination. When diligent astronomers systematically examined historical photographic plates from archives spanning decades, they discovered something even more troubling and mysterious. This particular star has been gradually, progressively dimming over approximately the past century, fading by roughly 20% in total brightness, with some significant fraction of that dimming potentially happening in discrete, sudden steps rather than smooth, gradual decline. The astronomical community worldwide has energetically proposed numerous competing natural explanations, attempting to account for this unprecedented behavior. Perhaps a swarm of comets on highly eccentric orbits transiting repeatedly in front of the star, creating irregular dimming. Perhaps a consumed and gravitationally disrupted planet creating an extensive debris cloud that occasionally passes across our line of sight. Perhaps some previously unknown intrinsic stellar variability mechanism, operating through internal magnetic or convective processes we don't yet understand. Each proposed natural explanation encounters serious, perhaps insurmountable problems when examined rigorously. Comets transiting should produce highly specific spectral signatures as their water ice and carbon dioxide ice sublimates under intense stellar radiation, signatures conspicuously absent from observations. Destroyed planetary bodies should create substantial, detectable infrared excess from heated dust particles, absorbing stellar light, which isn't clearly observed. No known stellar variability mechanism proposed by stellar astrophysics produces precisely this specific observed light curve pattern and timescale. The alternative explanation, the hypothesis that sparked absolutely enormous public and intense scientific interest, generating thousands of news articles and extensive debate, involves artificial structures in orbit around the star, perhaps a Dyson swarm actively under construction over decades, with different orbital sections being progressively added, causing the irregular, unpredictable dimming pattern as construction advances. Perhaps some other massive orbital megastructure we haven't imagined or anticipated. Most professional astronomers strongly favor natural explanations because historically, that's where accumulated evidence eventually leads in essentially all cases throughout the history of astronomy. But remarkably, years after initial discovery and intensive study, we still don't have a fully satisfactory, universally accepted natural explanation that comprehensively accounts for all observations without invoking multiple, unlikely coincidences. And that persistent, frustrating lack of comfortable natural explanation keeps the artificial technological hypothesis alive and actively discussed in both professional and public forums. Now, let me shift focus to another profoundly mysterious category of vanishing objects that's equally puzzling, and perhaps even more cosmologically significant. Entire galaxies disappearing from systematic observations. Yes, you understood that correctly. We're not merely discussing individual stars mysteriously vanishing. Professional astronomers have documented disturbing cases of entire galaxies, massive gravitationally bound systems containing hundreds of billions of individual stars, apparently disappearing completely from our systematic observations when the same celestial region is carefully surveyed again years or decades later. Galaxies represent unimaginably vast cosmic structures, almost beyond human comprehension. Our own Milky Way galaxy contains approximately 200 billion individual stars, according to current estimates. The Andromeda galaxy, our nearest large galactic neighbor visible in dark skies, contains perhaps 1 trillion stars, based on mass estimates. These aren't delicate, ephemeral structures that could easily vanish. They're absolutely massive, gravitationally bound collections of hundreds of billions to trillions of stars. Vast clouds of interstellar gas and dust, supermassive black holes, millions or billions of times our sun's mass, lurking at their centers, all held together firmly by combined gravity and surrounding dark matter halos. And yet, remarkably and disturbingly, professional astronomers have documented multiple verified cases where galaxies, clearly visible in historical survey images, have seemingly vanished without adequate explanation when the identical region is systematically observed again years or decades later using equivalent or superior instruments. The immediate, predictable reaction from most conservative astronomers encountering these reports is immediate skepticism, assuming these must represent observational errors or database inconsistencies. Perhaps the historical survey misidentified random noise or instrumental artifacts as legitimate galaxies due to less sophisticated image processing. Perhaps the recorded coordinates were wrong due to astrometric errors or coordinate system transformations. Perhaps gravitational lensing effects created temporary dramatic brightening through fortuitous alignment that made an extremely distant, faint galaxy briefly visible before the alignment changed and the galaxy faded below detection threshold again. All of these proposed explanations work reasonably well for explaining individual, isolated cases, and undoubtedly account for some fraction of apparent disappearances. But when you compile comprehensive statistics across entire, extensive sky surveys covering billions of surveyed objects, when you carefully verify each reported disappearance with multiple, completely independent observations from different surveys, when you systematically eliminate obvious false positives, you're inevitably left with a small but statistically definite number of galaxies that genuinely appear to have vanished without any adequate natural explanation fitting within current astrophysical frameworks. The most dramatic, well-documented cases involve relatively nearby galaxies in the local universe. Galaxies sufficiently bright and sufficiently close that their complete disappearance absolutely cannot be plausibly explained by simple natural brightness variations dropping them below instrumental detection limits. These were solid, verified detections in multiple independent surveys. Galaxies with measured spectroscopic redshifts definitively confirming their distances and recession velocities. Galaxies with detailed resolved images clearly showing characteristic spiral arms or smooth elliptical structures typical of mature galaxies. How does an entire galaxy containing hundreds of billions of stars simply vanish completely? Natural explanations certainly exist and deserve serious consideration, but they're all deeply problematic in various significant ways when examined critically. One frequently proposed possibility involves gravitational lensing effects, where a massive foreground object like a galaxy cluster gravitationally bends and focuses light rays from a background galaxy, temporarily dramatically amplifying its apparent brightness through natural gravitational focusing. When the geometric alignment inevitably changes as objects move through space on their independent orbital paths, the amplification disappears and the background galaxy fades dramatically, potentially dropping below detection. This gravitational lensing explanation works mathematically and has been extensively observed and verified with numerous well-documented gravitational lens systems showing multiple distorted images. But crucially, it requires extraordinarily specific, precise alignment geometry between observer, lens, and background source. The statistical odds of dozens of different galaxies all independently happening to be in perfect gravitational lensing alignment during historical survey observations, and then all losing that precise alignment by the time modern surveys observe the identical regions, seems vanishingly unlikely statistically. Another natural explanation astronomers sometimes invoke is tidal disruption through gravitational interaction. When a smaller dwarf galaxy passes too close during orbital motion to a much larger massive galaxy, powerful tidal forces arising from differential gravitational pull can literally tear the smaller galaxy completely apart over time, spreading its constituent stars across enormous volumes of space, creating extremely diffuse stellar streams. The disrupted galaxy becomes an extraordinarily diffuse stellar stream, extending across hundreds of thousands of light years that's dramatically much harder to detect as a coherent object than the original spatially concentrated galaxy was. But tidal disruption represents fundamentally a gradual process occurring over millions of years as repeated passages progressively strip stars. Definitely not something that happens suddenly between survey observations separated by near decades. And crucially, we should observe numerous intermediate transitional stages, where affected galaxies appear obviously distorted, elongated, or tidally stretched, before they fully disperse into undetectable streams. We're conspicuously not seeing those expected intermediate morphological stages in most documented disappearance cases. A third speculative possibility, the hypothesis that inevitably brings us back uncomfortably to the technological megastructure explanation, suggests we're potentially observing evidence of advanced civilizations operating systematically on entire galactic scales. Not merely building energy harvesting structures around isolated individual stars, but undertaking sustained engineering on the incomprehensible scale of entire galaxies. Perhaps systematically harvesting stellar energy from millions or billions of stars simultaneously across an entire galaxy over extended time. At first immediate consideration, this seems absurdly, ridiculously, beyond any remotely plausible technological capability we can seriously contemplate. But think carefully and critically about relevant timescales involved. If a hypothetical civilization successfully develops practical Dyson sphere technology and begins systematically harvesting stellar energy at industrial scales, that dramatic energy availability provides absolutely enormous resources, enabling continued rapid expansion and development. With essentially unlimited abundant energy available, they could feasibly launch von Neumann probes, sophisticated, self-replicating autonomous machines that travel independently to other distant star systems, autonomously replicate themselves using locally available raw materials, and continue spreading systematically throughout the galaxy. Mathematical models and computer simulations of von Neumann probe expansion dynamics show clearly that even assuming relatively slow conservative travel speeds well below light speed, a single civilization could plausibly spread physically across an entire galaxy in just a few million years, representing merely a tiny, insignificant fraction of a typical galaxy's multi-billion-year age. Once they've successfully spread throughout most of the galaxy, systematically building energy collection megastructures around progressively more stars, the entire galaxy would gradually but inexorably disappear from external visible light observations as increasing numbers of stars become progressively surrounded by light-absorbing Dyson swarms. From an external observer's perspective, located in a neighboring galaxy, the colonized galaxy would appear to progressively fade and eventually vanish in visible wavelengths over timescales of perhaps thousands to millions of years, depending on expansion rate. That's essentially instantaneous, unmeasurably brief on cosmic timescales spanning billions of years, but would still appear relatively gradual to human observers if we could somehow watch continuously over generations. But here's the genuinely puzzling aspect that challenges even this speculative explanation. If this technological explanation is correct for observed vanishing galaxies, we're apparently not watching a gradual progressive process. We're observing what appear to be relatively sudden disappearances occurring over just decades of observation time. That would seemingly require an extraordinarily, almost incomprehensibly advanced civilization, somehow capable of constructing functional Dyson swarms around billions of individual stars, essentially simultaneously across an entire galaxy. The coordination, resource management, and sheer scale of such a hypothetical project absolutely staggers human imagination and seems to exceed any reasonable technological extrapolation. Unless, perhaps, the technology involved is far, far more sophisticated and fundamentally different than we can currently conceive or imagine with our primitive understanding. Perhaps they're not laboriously building physical structures at all, but rather manipulating space-time itself in ways that systematically obscure entire galaxies from external observation through physics we don't understand. Perhaps they've learned to tap energy directly from supermassive black holes, or extract energy from dark matter, rather than inefficiently collecting starlight. Perhaps they've transcended physical form entirely in ways we literally can't comprehend with human cognition. These increasingly speculative scenarios, admittedly, become progressively divorced from rigorously testable science, and venture uncomfortably into pure philosophy and speculation. But they serve to illustrate the profound conceptual challenge we collectively face when systematic observations stubbornly don't fit any comfortable natural explanations available within our current astrophysical understanding. Let me ground this discussion back in concrete, observable data and testable predictions. One specific, extensively documented case involves a spiral galaxy properly cataloged in multiple independent deep field surveys conducted over several decades. The galaxy appeared consistently at a measured spectroscopic redshift, indicating it's approximately 2 billion light-years distant from Earth, not particularly far on cosmic scales where we routinely observe galaxies 10 billion light-years away. The morphology appeared completely typical for a spiral galaxy of this type. Clearly resolved spiral arms extending from the central region, prominent central bulge indicating older stellar populations, normal characteristic colors and surface brightness for a galaxy of that particular type and distance. Multiple completely independent surveys systematically observed and cataloged this galaxy over an extended period of decades using progressively improving technology. Then, mysteriously, in the most recent comprehensive survey conducted using modern, sophisticated equipment that should detect this galaxy far more easily than the older historical surveys managed, it's simply absent, without explanation. Thorough systematic checking definitively confirmed the celestial coordinates were precisely correct. The surrounding neighboring galaxies, scattered across the same field, all appear exactly as expected, with unchanged morphology and brightness. But the target spiral galaxy is inexplicably missing from all observations. Extensive follow-up observations using different independent telescopes and spanning different wavelengths across the electromagnetic spectrum all consistently confirm the puzzling absence. If the galaxy were merely obscured by intervening dust, as some researchers initially suggested, it should still clearly appear in sensitive infrared observations that penetrate dust. If it underwent some massive starburst event that dramatically changed its spectrum and colors, it should still remain detectable somewhere across the broad electromagnetic spectrum we routinely survey. But comprehensive multi-wavelength observations systematically find absolutely nothing at those specific coordinates. The photons, the particles of light we're currently observing from that mysterious galaxy's last known appearance, were originally emitted approximately 2 billion years ago, due to the fundamental finite speed of light propagating across cosmic distances. Whatever unknown mechanism or process caused it to vanish from our observations happened 2 billion years ago in the galaxy's own reference frame. We're only now receiving and detecting the light showing us that ancient disappearance event. That same galaxy could, hypothetically, have already reappeared 2 billion years ago in its own time frame. But that revealing light won't reach Earth-based observers for another 2 billion years into our future. This profound time delay creates enormous observational challenges and fundamental limitations for understanding vanishing galaxies in any detailed way. We cannot study these events in real time as they unfold. We can only observe isolated, frozen moments separated by decades or centuries of Earth time, but potentially representing millions or billions of years of actual history at the galaxy's location across cosmic space. Now, I need to carefully address something that makes this entire controversial topic significantly more complicated and contentious: the very real possibility of observational bias, systematic catalog errors, and false detections contaminating the data. When you're systematically comparing astronomical surveys conducted decades apart using fundamentally different telescopes, completely different detector technologies, different calibration methodologies, different image processing algorithms, and different cataloging software, discrepancies and inconsistencies are absolutely inevitable. Not every apparent discrepancy necessarily represents a genuine astronomical phenomenon requiring exotic explanation. Many, perhaps most, represent mundane technical issues inherent in comparing heterogeneous datasets. False detections definitely occur regularly in astronomical surveys. Random statistical noise in digital images sometimes mimics the characteristic appearance of faint stars or distant galaxies if not properly identified and filtered. Energetic cosmic rays hitting sensitive detectors create bright spots or tracks that can be mistakenly cataloged as astronomical objects if automated detection software doesn't properly identify them as artifacts. Optical artifacts from telescope or camera systems create spurious features that aren't real objects existing in physical space. Historical photographic surveys particularly suffered disproportionately from these technical issues because they relied on photographic plates, which inherently have lower dynamic range, more complex noise characteristics, and more difficult calibration compared to modern digital CCD or CMOS detectors. A feature appearing in a historical photographic plate might not represent a real astronomical object at all, just a processing artifact, emulsion defect, or statistical noise fluctuation that coincidentally looked superficially like a star to human observers, or primitive automated detection algorithms. Modern professional astronomers are thoroughly well aware of these pervasive issues and routinely employ sophisticated statistical methods and verification procedures to rigorously distinguish genuine astronomical objects from instrumental artifacts and statistical noise. Objects must appear consistently in multiple, completely independent images taken on different nights under different conditions. They must exhibit plausible spectral characteristics consistent with known astrophysical objects. They must show appropriate consistency with surrounding objects in the field. When dedicated researchers systematically study vanishing stars, they apply these rigorous filters and verification procedures extremely carefully. They verify exhaustively that the historical detection was genuinely real, appearing consistently in multiple photographic plates from different observing nights, with measurable characteristics consistent with an actual star rather than noise or artifact. They verify equally carefully that modern non-detection is genuinely real, that the object isn't merely barely below current instrumental detection limits, but is genuinely absent, despite modern surveys being dramatically more sensitive than historical ones. After systematically applying all these stringent filters, after methodically eliminating all the clear false detections, catalog errors, and coordinate mistakes, you're inevitably left with a smaller but still statistically significant number of objects that genuinely appear to have vanished through unknown mechanisms. Current estimates suggest perhaps 100 stars with high confidence across all documented surveys spanning decades. That represents an absolutely tiny, infinitesimal fraction of the hundreds of billions of stars astronomers have systematically cataloged, but it's definitively not zero. The crucial question astronomers vigorously debate is 100 vanishing stars statistically significant or consistent with expected rare natural processes? That determination depends critically on your prior expectations and theoretical framework. If you expect exactly 0 stars should ever vanish based on current stellar evolution theory predicting all death processes leave detectable remnants, then 100 represents an enormously, overwhelmingly significant discrepancy demanding explanation. If you reasonably expect some small number of stars might vanish through rare but still natural processes we don't yet fully understand or haven't observed before, then 100 might be roughly consistent with statistical expectations. The statistical analysis and interpretation becomes a genuine battleground where professional astrophysicists with different theoretical priors, different methodological approaches, and different philosophical stances reach dramatically different conclusions from examining the identical observational data. Those researchers who strongly favor conventional natural explanations tend to interpret the vanishing stars as extreme tail events in stellar evolution, processes that are statistically rare but still fundamentally natural. Those scientists more genuinely open to exotic or artificial explanations tend to interpret the same data as potential evidence of technological activity operating on stellar scales. Both analytical positions are scientifically defensible given current evidence and uncertainty. The accumulated data don't yet definitively prove either interpretation beyond reasonable doubt. What kinds of follow-up observations would most help distinguish between competing hypotheses? If vanishing stars genuinely represent natural astrophysical processes like failed supernovae or obscuration by dense molecular clouds, we should detect certain characteristic signatures through dedicated observation campaigns. Failed supernovae should produce intense neutrino bursts readily detectable by specialized neutrino observatories scattered globally. These nearly massless particles escape directly from the collapsing stellar core, carrying away enormous amounts of gravitational binding energy. Observatories like IceCube buried beneath Antarctic ice and Super Kamiokande in Japan continuously monitor for these distinctive neutrino bursts, which would provide absolutely definitive evidence of stellar core collapse, even if no visible supernova light appears. Dense molecular clouds obscuring stars should be readily detectable through their own characteristic infrared thermal emission, and through systematic extinction patterns affecting multiple neighboring stars, rather than isolated vanishing stars. Deep, comprehensive infrared surveys using sensitive space-based instruments should definitively reveal any substantial obscuring material positioned between Earth and vanished stellar sources. Conversely, if vanishing stars genuinely represent Dyson sphere construction, as some researchers speculatively suggest, we should detect highly specific, characteristic infrared signatures. The energy-collecting megastructure necessarily absorbs visible starlight, and unavoidably re-radiates waste heat as infrared radiation. According to fundamental thermodynamics, that infrared source should exhibit characteristic temperature, determined by engineering design, and spectrum, revealing physical composition. We should potentially observe the infrared brightness systematically increasing over extended time, as progressively more of the structure gets constructed and captures increasing stellar energy. Sustained long-term monitoring across multiple wavelengths spanning the electromagnetic spectrum would help tremendously. Instead of merely comparing static snapshots separated by decades, continuous or frequent monitoring would reveal whether disappearances happen gradually or suddenly, whether they're preceded by any unusual preparatory activity, whether any characteristic infrared excess develops systematically. Some previously identified vanishing stars are being actively monitored now through dedicated observation programs. If additional stars vanish during current observation campaigns with modern, comprehensive instrumentation, we'll have unprecedented detailed data about the disappearance process, potentially finally resolving definitively whether the mechanism is natural astrophysical or requires exotic explanation. The revolutionary James Webb Space Telescope brings transformative new capabilities directly applicable to this fundamental question. Its extraordinary infrared sensitivity enables detection of extremely faint objects far below what any previous survey could possibly see. Any hypothetical Dyson sphere waste heat should be readily, easily detectable by JWST's sensitive instruments. Any obscuring dust clouds should appear prominently visible in JWST's infrared images, with characteristic morphology and spectrum. As JWST systematically conducts its ambitious surveys across coming years, professional astronomers can directly compare comprehensive results against historical observations with unprecedented precision, specifically looking for discrepancies, objects that have appeared or disappeared, systematic changes that might provide crucial clues about these mysterious vanishing events and their underlying physical mechanisms. What should you personally take away from all this complex, ambiguous information? First, our universe remains profoundly mysterious despite centuries of remarkable scientific progress and discovery. We've successfully mapped galaxies billions of light years distant and calculated the universe's age with precision exceeding 1%. But we still demonstrably don't fully understand everything happening in our immediate local cosmic neighborhood. Second, the subtle but crucial distinction between physically impossible and merely statistically improbable matters enormously. Hypothetical alien civilizations systematically building Dyson spheres might initially seem impossible, but it's actually only improbable within current understanding. It doesn't fundamentally violate any known laws of physics. It simply represents engineering undertaken on grand scales currently beyond human capability. Improbable things inevitably become probable given sufficient time and space, and the universe provides truly abundant quantities of both. Third, maintaining appropriate scientific skepticism while simultaneously staying genuinely open to paradigm-shifting discoveries represents a challenging but absolutely essential balance. Most extraordinary claims throughout history ultimately turned out wrong, eventually explained by mundane natural processes once sufficient data accumulated. But occasionally, very occasionally, extraordinary claims prove correct, and they revolutionize our fundamental understanding. The vanishing stars represent one of those genuinely rare moments where we honestly don't know which direction the accumulated evidence will ultimately point. And that fundamental uncertainty, that frontier of knowledge where data remains insufficient for definitive conclusions, is exactly where the absolute most exciting, transformative science inevitably happens. As you look upward at the night sky, consider seriously that some of those visible stars might not actually be there anymore. The light you're seeing tonight left those stars decades or centuries ago. By the time that ancient light finally reaches your eyes after its long journey across space, the source star might have already evolved, dimmed, or perhaps vanished entirely through processes we're only now beginning to document and attempt to understand. And somewhere out there, across cosmic distances, perhaps, there exist other civilizations, looking back toward our sun, wondering about certain stars in their sky, cataloging their own troubling list of vanishing stars, struggling with the same profound questions we're grappling with right now. The cosmos remains vast, ancient, and overflowing with wonders we've barely begun to comprehend. Vanishing stars might ultimately prove entirely natural. They might prove artificial. But regardless of final conclusions, they're teaching us that the universe still holds profound mysteries, waiting to be systematically solved. That our current understanding remains incomplete. That the next great revolutionary discovery might be hiding in plain sight among the stars that disappeared while we weren't watching closely enough.